Welcome to the very first video on Fractal Universe channel. If you followed my work on Lato files, you know I've explored mysteries like UAPs, but lately I've been obsessed with something even bigger, and that's the hidden patterns that connect everything in existence. Today, we're diving into the universe's favorite number, 10 to the power of 3, or 1,000. It's not just a random figure. It's a recurring scale that pops up everywhere, from protons to superclusters, with an average jump of about 10 to the 3 in size between fundamental structures. I'll be stepping through the universe using an app. It's called Universe in a Nutshell app to show you these scales live. If you like mind-bending science and mind-bending theories, you've come to the right place. Thank you for being here. All right, let's break this down using verified data from peer-reviewed sources as detailed in the scale table from my upcoming book's Appendix A. Imagine zooming through the universe, and you'll notice fundamental structures emerging every roughly 1,000-fold increase in size. That's 10 to the 3, with an average logarithmic jump of 2.98 across the ladder. Starting small, the proton, the building block of atomic nuclei, has a radius of about 8.4 times 10 to the minus 16 meters. That's from CoData Data 2018. Now let's jump up by around 10 to the 5. It's a bigger leap here, and you hit the atomic orbital of hydrogen at 5.29 times 10 to the minus 11 meters. Next, let's scale up by about 10 to the 2.3 to the ribosome. That's a universal protein machine in cells at 10 to the minus 8 meters. That number comes from BioNumbers. Again, these are all peer-reviewed sources. So another jump of 10 to the 2. That's to a bacterium like E. coli, and that's at 10 to the minus 6 meters. So let me scan to 10 to the minus 6 meters. You see mitochondria at 10 to the minus 7. Largest virus, 10 to the minus 7. And now we start seeing at 10 to the minus 6. We start seeing bacterium like E. coli. So from there, let's multiply it again by roughly 3. It's exactly 10 to the 2.7 actually. And at 10 to the minus 4 meters, we're going to see C. elegans. That's a simple multicellular organism. And this source comes from NCBI data. You notice here you have tardigrades also. It's a salt grain, the smallest plant, amoebas. And then from here, this is going to blow your mind. So now we go from 10 to the minus 3. And if we jump up again by 1,000, we get to 10 to the 0. And so what is going to be at 10 to the 0? Can you guess? I don't think we'll have to name a reference here. We're passing pennies, hummingbird, human brain at 10 to the minus 1. And now we're getting to, you guessed it, 10 to the minus 0. And that is where we live. Okay, so at humans. But think about that. You jump from 1,000,000 times larger than a bacterium, so 10 to the 6 is a human. And that's really 2 10 to the 3 jumps. Let's not stop at human. Let's keep going. So what happens if we keep going? Another 10 to the 3. What do you think we're going to find at the next major step in universe size? At 10 to the 3. What are we going to find? Let's see. We're passing a football field. We're passing the Great Pyramid, 10 to the 2. We're getting to Tesla Gigafactory, Burj Khalifa, Vatican City. Central Park. And then as we get to 10 to the 3, Mount Everest, Large Hadron Collider. So what do we see at this size? We see cities, right? That is amazing, right? Another 10 to the 3 step up from humans, we get cities. And this source comes from Betancourt in 2007 and West in 2017, if you've heard of the book Scale. So now let's go up another 10 to the 3 jump. And this is actually a little bit more than that. There is some variation in this, but we're looking again at the fundamental units. So if we go up another, in this case, 3.8, so 10 to the 3.8, what do you think we're going to find at the next major step? So we're passing Grand Canyon, we're passing Switzerland. We have Florida now, 10 to the 5. We have Ceres, so small moons are 10 to the 5. This is radius. We have all water on Earth, 10 to the 5. And now we have USA approaching 10 to the 6. Okay. And what do we see in this order of magnitude? So if we jump up from cities, 10 to the 3.8, right? There is some variation in there. We get to Earth. So we get to the actual radius of Earth. And that's from IAU 2015. Again, I think this is just amazing. Now let's keep going. So if we go from this scale, 10 to the 6, and we go up 10 to the 2, what do you think we're going to find at the next jump? Remember the last one was 3.8, so it was a little bit bigger. There is some variation. But overall, the average log is 2.98. So if we go up 10 to the 9, what do you think we're going to find there? That's right, our sun, right? So the next step from Earth is the sun. I think that's amazing. So now let's jump up another step. Okay, in this case, again, it's a little bit different. And there's different ways to define this next step. But if we jump up 3.8, what do you think we're going to find at the next step up of 1,000? So now we're passing a supermassive black hole. That's at 10 to the 10th. Now we start seeing larger stars. Then we have the black hole in the Milky Way. The center of the black hole is actually 10 to the 10th. Keep going. We have Polaris. We have much larger stars now. You're seeing the distance from the sun to the Earth, passing that at 10 to the 10th. We speed it up. 10 to the 11th now. We have pistol stars. Again, larger stars. Betelgeuse. But what do you think we're going to find at 10 to the 12th? This is the next step up. Canis Majoris. Okay, you should start seeing it here. We have the Kuiper Belt. Okay, so basically the solar system. So if you jump up from the size of the sun by radius, 10 to the 3.8, you get out to Neptune's orbit. And that's at 4.5 times 10 to the 12 meters. So again, it's at 10 to the 12th. And now let's go to the next step, right? So the solar system, Neptune's orbit, but the solar system is actually much bigger than you are led to believe, at least what I learned in school. Okay, so what we have is at the next step up from 10 to the 12, 10 to the 15th. Do you know it's at 10 to the 15th? But what is actually at 10 to the 15th was we're passing Nebula, Cat's Eye Nebula, Clown Face Nebula, Homunculus Nebula. Okay, at 10 to the 15th. What we actually see there is also the Oort cloud. So that's actually the large spherical object that encompasses our whole solar system. And outside of the Oort cloud is our sun doesn't have any influence. And that's at 10 to the 15. And that's an exact 10 to the 3 jump. So 1,000 jump above Neptune's orbit. Again, I think this is just miraculous. And the Oort cloud is fundamental. So now let's step up again. What do you think we're going to find there? Okay, so as we're Zooming out here, you have nebula, larger and larger nebulas. You have the distance from the sun to the closest star. Okay, we're passing that. That's at 10 to the 16th. Now we have the Orion Nebula. We're passing that, still at 10 to the 16th. I need to speed up. We have the American Nebula, even bigger, 10 to the 17th. We have the Lagoon Nebula, again, larger. But now we're seeing Mega Centauri. Okay, so Mega Centauri, great nebula in Carina. If I go a little bit further out, let's see what we find. At 10 to the 18th, you're going to start finding what I like to call it is a star cluster. That's a stellar neighborhood. So this isn't a galaxy cluster. Okay, this is a cluster of stars. So it's just going to be at 10 to the 18th. The galaxy will actually be made up of many thousands to millions of these star clusters. Okay, now from the open cluster at 4.7 times 10 to the 17th, so basically 10 to the 18th meters, what do you think we're going to find at the next jump up of 1,000? So as we go up, we're passing small Magellanic Cloud, we're passing the large Magellanic Cloud. We see 50,000 light years. We're passing Sombrero Galaxy, Triangulum Galaxy, Whirlpool Galaxy. And then what do we find at the next step up from star cluster? Again, 10 to the 3, the Milky Way. So the Milky Way is, at radius is 5 times 10 to the 20 meters. So again, if you round that up, it's 10 to the 21 meters. And there is some variation. Okay, you see the Milky Way is smaller than Andromeda, right? But it's larger than other galaxies like dwarf galaxies. So it is a full-size galaxy. And we see from galaxies, they are in the order of 10 to the 21 meters across. That's, again, the average log scale is 2.98 across all these scales. It's just miraculous to me. Okay, and we're almost done. We only have 2 more steps up. So with only 2 more steps up, if we go up from Milky Way, if we go up 10 to the 3.1, what do you guess we're going to find at 10 to the 3.1? So distance to the next galaxy, we're passing that at 10 to the 22. Abell 2029, that's a famous cluster. We see our local group. We see Fornax cluster. That is a small, very small galaxy cluster. And now we're getting to 10 to the 24. And what do we see there is our very own, the objects that we are inside of, that our galaxy is inside of. And we get to the Virgo supercluster. And so the Virgo supercluster is at 6.9 times 10 to the 23 meters. So 10 to the 24 meters, you round up. So again, I think that is miraculous. And then finally, if we step up 1 more level, 10 to the 2.8, we get to, can you guess it? So let's see, distance to the great attractor. It's the last level. So I would hope you can guess it. We have larger supercluster, supercluster complex. We have the Sloan Great Wall, if you've ever heard of that. We have the largest known quasar group. That's a 10 to the 25. We have the distance to the Hubble Deep Field, 13 billion years. And then we finally arrive when we do another almost perfect 10 to the 3 step from the Virgo supercluster, we get to the entire observable universe. So I just think this is amazing. I am extremely over the moon excited about this. I don't think this is a coincidence. You have the average scale jump is 10 to the 2.98, essentially 10 to the 3. And that's across 15 fundamental structures spanning 42 orders of magnitude. That's a lot of orders. So mathematicians call it fractal scaling. So that's when self-similar patterns repeat across scales. Benoit Mandelbrot showed how this applies to nature. That's from coastlines to markets. But here, it's tied to how complexity builds. So every 1,000-fold increase allows new organization. It's like steps in a cosmic ladder. In biology, we see this in how cells form organisms, then societies. In astronomy, structures like galaxies mirror neural networks. This app just makes it super vivid. Link is in the description to the app. If you want to check it out, you can click on each one of these objects and it gives you detailed information. So when I zoom from the proton to the sun, that's a 10 to the 23.92 jump. So that is close to a perfect cosmic octave of 10 to the 24, which we will explore in future videos. But this 10 to the 3 rhythm really suggests through observations that the universe is structured, and it's perhaps even fractal all the way up. So that's the universe's favorite number, 10 to the 3. It emerges from real data. And I believe I can back it up with statistical significance. For the full scale table and sources, check the appendix in my upcoming book, Fractal Universe. If this blew your mind like it did to mine, thank you for watching. Please hit the like button, leave a comment, and consider subscribing. I will be posting a video every week. So next time we'll explore the actual fractals, the fractal math, as the secret architecture. Thank you so much for watching. You can get more insight and support me on patreon.com/Chris Lato. But until then, have a great rest of your day. And I think 2026 is going to be amazing. We're going to learn so much about the universe. And I think one of the things we're going to find out is that it is much larger than we can imagine and much more interconnected than we can imagine. Although I know many of you feel that it is interconnected. And I'm just so excited that we actually have the tools. Now we have the mathematical tools with AI and all the data from so many decades to look at it. So excited. Have a great rest of your day. Peace.